first, what is corona exactly? Means that this is particular conductor, and this is cross section of that conductor, and nearby that conductor there is a glowing surface, right? So such phenomena means it is violet colored glow surface over there. So this phenomena is happening in case of conductor. What is corona? Corona is nothing but the luminous discharge due to ionization of air surrounding the electrode caused by voltage gradient exceeding the certain critical value. You know that for air, background voltage is 30 kV per centimeter, and when that voltage gradient, you know that what is voltage gradient exactly? Let us say suppose this is a conductor, and here nearby this conductor, let us say suppose at this point the voltage gradient or electric voltage trace, it is 400 kV. Whenever we are moving away from this conductor, the voltage stress, dielectric voltage stress, it is going to decrease if we are moving towards this direction. Let us say suppose at this position it is 300, here it is 200, it is 100. That means this voltage electrostatic field around that conductor, it decreases whenever we are moving away from the conductor, and that decrease in electric stress, electric field, it is called as a voltage gradient. So it is nothing but the luminous discharge due to ionization of air surrounding the air, and it is caused by a voltage gradient exceeding a certain critical value. And you know that for air it is 30 kV per centimeter. Whenever that voltage or voltage gradient increases beyond that 30 kV per centimeter for normal temperature, in case of rain, it may vary, or bad weather condition, it may vary. Okay, so this is nothing but the example on of conductor on corona. You can see a violet glow around the conductor, and it is generally most of the time it is observed at the time of रेनी सीझन. म्हणजे तुम्ही पाहू शकता की कंडक्टर बऱ्याच वेळा असा दिसतो, किंवा एखादा ओव्हरहेड कंडक्टर असेल, म्हणजे छोटी जरी ट्रान्समिशन लाईन असेल आपली 22 केव्ही किंवा 11 केव्हीची, तर तिथे पण कधी कधी एखादा कंडक्टर जर ब्रेक झालेला असेल इन्सुलेटरच्या तिथे, किंवा त्याचा स्टँड कट झाला असेल, तर तिथे पण कधी कधी असं स्पार्किंग दिसतं. बट जनरली दिस इज ऑब्झर्व whenever your system voltage increases beyond 500 kV. Are you getting or not? Am I audible? Yes, please.
Yes, sir.
Okay, good. Now, so what is exactly that noise? Why exactly that noise is produced in case of corona? So, see, corona from conductors and hardware may cause audible noise, or it may be radio noise, and this audible noise from conductor may violate noise standard. Means जे नॉईजचे स्टँडर्ड्स आहेत, मी जसं म्हटलं की कालच्या आपण लेक्चरमध्ये बघितलं की द अलाउएबल noise level for particular at the edge of right of way, it is 52 dB. But this audible noise, it may be greater than that, whatever the limit set for corona, and it violates the noise standard. The radio noise from conductor may interfere with communication or navigation. जे कम्युनिकेशन सिग्नल सेंड केलेले असतात, किंवा काही कम्युनिकेशन जी वायर असते, तर त्या किंवा एखादा टेलिफोन कंडक्टर असेल किंवा टी व्ही आहे, तर त्यांचे जे काही सिग्नल्स आहेत त्यामध्ये काय होतं, इंटरफरन्स क्रिएट होतो, अँड इट इज गोइंग टू create problem for that particular person which is operating nearby that. So corona loss may be significant when compared with resistive loss of conductor. And resistive loss जर consider केला तर it is least, or we can say little bit more significant as compared to resistive loss. Means I square R loss जर consider केला as comparatively corona loss, it may be significant. Okay, so next point is corona can cause possible of insulator. This is nothing but the corona discharge current, and here you can see that it is drastically increased, and means This is build up and this is discharge. And the period, it is in between 0.01 to 0.1 microsecond. So it is very impulse current, means impulsive discharge is there. Okay, which are the physical parameters of corona? It is caused by ionization of the air surrounding the electrode, or we can say conductor. It is nothing but the function of voltage. Why it is function of voltage? Because whenever that voltage increases beyond critical descriptive voltage, it occurs, and it is also function of relative air density. See, in case of normal weather condition or fair weather condition, the air density is having very high value. But if we consider rainy season, the moisture content in the air is considerable, or it is having more moisture in the air, due to which air density decreases. So again, corona is nothing but the function of relative air density. It is a function of relative humidity. पाऊस आला किंवा रेनी सीझन असेल तर एअरमधली ह्युमिडिटी ऑब्व्हियसली वाढणार आहे. सो इट इज ऑल्सो function of relative humidity. Okay, so on which factor this corona is not, means it is not only depends on electric field, but also it is depends on which other factors. It is function of electric field on surface of the electrode. सरफेसची जी इलेक्ट्रिक फील्ड आहे ती व्हॅरी होते whenever we are moving away from the, and due to which it is called as a voltage gradient. Okay, generally voltage gradient is denoted by dv by dx. X is nothing but the distance, v is nothing but the voltage. So dv by dx, it denotes voltage changes with the distance, right? So again, the electric field on the surface of electrode or conductor, it is a function of radius of curvature of electrode. You know that if conductor is having uh, higher diameter, corona is lesser. Okay, so corona is a function of rate of decay of electric field away from the electrode, that is voltage gradient. Now, let us suppose, see, as I told you, selecting the conductor with smallest electric field at its surface is not correct. It is not correct because we have to, means to reduce the losses, we have to go for higher voltages, and it is not practically possible to select a conductor with smallest electric field at the surface. So one utility found out that the simply choosing large diameter conductors did not well work because the electric field decayed solid away from the surface. एक ऑप्शन तर आहे की लार्ज डायमीटर कंडक्टर आपण यूज करू शकतो टू रिड्यूस द corona, but whenever we are going for larger diameter conductor, the electric field decayed slowly away from the surface. Okay, so this corona is having inverse relationship with air density, means air density increases, corona decreases, air density decreases, corona increases. And what are the reason to decrease the air density? There may be some moisture content inside the air. The standard line designs that performs well at sea levels may have significant corona issues if used on lines that is installed over mountain area. म्हणजे एखादी कंडक्टर आहे, एखादा पर्टिक्युलर लाईन आहे, सेम कंडक्टर आहे, सेम स्पेसिफिकेशन आहे, ऑपरेटिंग व्होल्टेज पण तेच आहे, बट इट इज गिविंग डिफरंट रिस्पॉन्सेस ओव्हर सी अँड ओव्हर द माउंटन. आता सी लेवल असेल तिथे मॉइश्चर जास्त असू शकतं. माउंटनमध्ये the air is that much of, means that air density is more as compared to the sea level. So what will happen? The corona issue, it may be different in both the cases. Okay, so corona has inverse relationship with humidity at power frequency. Let us suppose 50 hertz frequency is there. So humidity increases, corona decreases, humidity decreases, corona, as there is a inverse relationship between corona and humidity. Then fair weather corona is more prevalent in low humidity environment. Okay, so let us talk about the effect of surface condition on corona. The corona is enhanced by irregularities on the conductor surface. This is already we have discussed that if the surface is not regular, it is not proper. In that case, it may cause. And what is the reason to irregularities on the conductor surface? It is nothing but the dust, insect, burr, scratches, and water drops present on new conductor. These are the some reason की आता एखादा कंडक्टर आहे तो एकदम प्रॉपर रेग्युलर आहे तिथे कोरोना लॉस ऑब्विसली कमी असणार आहे बट देर आर सम रिझन ड्यू टू विच it becomes irregularities. Those are nothing but dust, insect, burr, scratches, and it may cause by any other reason. Means scratches maybe conductor इरेक्ट करताना पण होऊ शकतात किंवा जसं आपण म्हटलेलं की ड्यू टू करोना देर इज अ फॉर्मेशन ऑफ ओझोन दॅट ओझोन कॉजेस यस it may oxidize that conductor and the surface become irregular. So it is generally greater on new conductor and will decrease to a steady state value over a period of approximately 1 year in service. Means in case of new conductor, it is generally occurred with higher value and after a particular year of 1 year, let us say after 1 year of service, it is having constant value of loss. You know that corona is significantly increase in fall weather. Now, what is the special problem for voltage upgrade? If the voltage of transmission line is increased, electric field at the surface of line conductor will increase. This will increase. This will cause additional corona. Yes, obviously, with existing system, with existing design, if we are going to increase the voltage level, then electric field at the surface of that conductor, it is generally, uh, obviously, it is going to increase. And you know that increase in electric field at surface, it causes increase in corona loss. So, which are the, we can say, practical consequences? The first one is larger conductor betters. These are the methods or measures which are used to reduce the corona. The first is larger conductor better to a point is for particular, let us say, up to several limit of voltage. Use conductor bundles to reduce the corona. This is already studied. The bundle conductor use करणार असेल तर corona reduce होणार आहे. Then corona phenomena much worse in fall weather high altitude. But this is not in our hand to reduce to make as possible as good weather condition because it is totally depends on nature conditions. Now compact lines are more susceptible. Then new conductors can lead to a poor corona performance for a while. But this is only for just now we have seen it is only for a year of time. Okay, so what is exactly radio noise and which are the cautions regarding radio noise? Let us see. The radio noise from corona should not be confused with radio noise generated by spark discharge. See, spark discharge and corona जो काही noise आहे. These are the two different things. So high frequency complaints are almost always due to spark. म्हणजे इथे काय सांगितलं की ज्या कंप्लेंट्स येतात लोकांच्या maximum complaints it is due to the noise due to the spark and the cause of spark discharges can be located and repaired. एखाद्या ठिकाणी कंडक्टर ब्रेक झालेला आहे तिथे स्पार्क होतोय तिथे नॉइज क्रिएट होतोय such things generally can be observed by number of times and it is means complaints are made and it is generally solved as early as possible but corona is डिझाईन इशू मीन्स ड्यू टू डिझाईन इशू जसं मी म्हटलं की प्रिव्हियस लेक्चरमध्ये सांगितलं जिथे कंडक्टरच्या सरफेस इरेग्युलर आहे किंवा टॉवर जे आहेत इन्सुलेटर्स आहेत तिथे स्पाइक्स आहेत हे डिझाईन प्रॉब्लेम्स आहेत ते ड्यू टू दॅट डिझाईन प्रॉब्लेम्स करोना इज जनरली occurring. So radio noise caused by corona cannot be reduced by changing the line configuration near where the noise problem is occurring. The source of problem can be several miles away. Okay. जसं आता आपण म्हटलं की जो स्पार्कमुळे नॉईज आहे तो आपण लगेच सॉल्व्ह करू शकतो. आणि तिथला कंडक्टर आहे तो रिपेअर करून तिथे जो काही ब्रेक झालेला आहे तो रिपेअर करून तो नॉईज कमी होऊ शकतो ड्यू टू द दॅट इज नॉईज ड्यू टू द स्पार्क. बट इन केस ऑफ करोना इट इज नॉट at all located. Now, what is audible noise? It can get broadband noise and hum. म्हणजे क्रॅकिंग व्हॉइस जो आहे तो क्रिएट होतो. सो लाऊड can affect audible noise. For measurement, these are the standard which are used for measurement of audible noise. Mm, let it be. Okay, so these are the some ranges. See, audible noise, it is from 30 meter from center line. If we consider a particular tower, from that tower, let us say suppose right of way is 30 meter and it is measured at 30 meter from that tower, and these are the some ranges. Let us say suppose 50 decibel, there is no complaint. Up to 55 to let us say suppose here it is near about 58. There are moderate complaint, and that 58 onwards there are numerous complaint. So generally the common design limit is, yesterday we have seen 52 dBA, but as per BPA study it is 53 dBA. So some studies may give different result, but as per our yesterday's discussion, the limit for audible noise is at the age of right of way is 52 dBA. So what is corona loss? Whenever corona loss occurs on a transmission line, there is a corresponding loss of energy called as a corona loss, and this loss is one of the reason why the transmission of electric energy between 2 points is not perfect. See, loss, you know that loss is nothing but means whatever the amount of energy we are transferring from one point to another point. Due to loss, the total energy is not transferred towards the user end. It causes the reduction in energy supplied. So when can it be a problem? Generally, corona loss is significantly less than resistive loss. However, at higher voltages, high altitude, and during fall weather conditions, corona loss can actually exceed resistive loss. See, corona loss काय resistive loss जसं compare केलं in case of normal weather condition, it is very much less. But in case of fall weather condition, it is exceeding the resistive loss and it becomes major, uh, and we have to, that's why we have to reduce it. So whenever corona occurs on a transmission line, there is a corresponding loss of energy called as a corona loss, and this loss is one of the reason why the transmission of electric energy between 2 points is not perfect, and generally corona loss is significantly less than just now we have seen. So these are the some voltage level and bundle conductor configuration. This is power which is to be transmitted, and we are going to see corona loss and I square R loss. So let us suppose the transmission voltage is 362 kV. The bundle means there are two conductors in a bundle which is having diameter of 3.16. The power to be transmitted is 400 MVA. So what is I square R loss? It is 41 kilowatt per kilometer. And corona loss, let us suppose average it is 2 and maximum it is 26 kilowatt per kilometer. Now let us move towards 550. See, yesterday I told you that above 500 kV it becomes major. So if we consider 550 and the number of conductors in a bundle is 3, which is having diameter of 3.3, the power to be transmitted 900 MVA. Here you can observe that as the corona loss becomes major because it exceeded I square R loss here 78 because the voltage level is exceeded above 500 kV, and in case 100 kV line with 4 bundled conductor means 4 conductor in a bundle to transfer 2000 megawatt of mega volt ampere power, I square R loss is 93, but coronal loss is 208. That is maximum coronal loss is 208 kilowatt per kilometer. And these are the examples at sea level. It may give different result at mountain because at that time means at the mountain what is happening, the weather condition is as compared to sea level it is good.